All right, so if we were to run the bending test, this is the sort of setup that you see, okay? We had a piece of lumber that was 3 foot long, and it would be setting on some supports, okay? It would be loaded with a point load in the middle of the span. So the first question that people always get wrong is, what's the span? Is the span 36 inches? That's no. That's the physical length of the beam. Because the beam sits on supports, the typical assumption is that the reaction acts at the halfway point in that support. So if this support was, let's say, 2 inches long, we'd assume the reaction would be in 1 inch. Okay? So what you're interested in when you're doing structural calculations is what is the span length. So the span length would be, in our case, we're really doing this, would be 32 inches. Okay? All right. So the second thing that people always get wrong in this test is they want to say that the failure stress was P, maximum load, over A. All right? Why is that wrong? Why is P over A wrong? Well, who's my people taking strength of materials right now? When do you, come on. Nobody's taking strength of materials? Who's taking strength of materials?
It's like 9 months ago.
No, right now. There's people taking it right now, isn't there? There's just all people that took it 9 months ago. Oh, well, all right. P over A is for things like compression, tension, some shear. Okay? This setup is bending. What's the bending stress formula? MC over I. Are you taking strength of materials right now? Okay, so MC over I. Don't say P over A for this. For what we just got done with, fine. But MC over I. So when you look at the cross section of this beam, does it have a cross-sectional area? Yes. Is area part of MC over I? No. Okay, it is. I mean, it's in the moment of inertia, but you don't. Don't be using it. All right. Use moment of inertia. That shape for this 2x4, which is 1.5 inches by 3.5 inches, like we said in the lecture, that shape is what? What is the shape? It's what? A rectangle. A rectangle is a standard shape. Does a standard shape have a standard formula for moment of inertia about the centroid of a rectangle? Yes. Very, very common. Anybody want to tender a guess as to what that is? What's that formula? I'll start it for you. 1/12 BH cubed. There you go. Do you see that centroidal axis in there? Imagine that centroidal axis. What's the C value? C value is the distance from the axis to the outside edge. It's halfway of the depth, half of the depth. All right? So MC over I, you can look in a standard formula what I is. You know what C is. What is moment? Moment is the bending moment. The bending moment caused by a load at the center part, midway through the span. Okay? How are you going to find the moment? I got a load here. How are you going to find the moment? Well, what I would do is one of two things. One is your favorite topic in statics and strength of materials was shear moment diagrams. So construct either a little shear diagram and a little moment diagram to figure out what the moment was. I mean, again, this is about as simple a shear diagram or moment diagram as you can get. You either do that or you go someplace to a resource, because again, simple beam, load in the middle, that's a very standard case. So anytime you have a standard case, there's many resources out there that give you all the standard formulas for it. Formulas for reactions, formulas for deflection, formula for maximum shear, even what the shear and moment diagram look like, you know, they give it to you. So, all right? So again, you have to come up with bending stress, but it's a simple formula. That's it. That's good.